From shaky baby steps to serving coffee on its own, Figure AI's humanoid robots have come a long way. But what really changed between Figure 01, 02, and the brand new Figure 03? And why do engineers believe these machines could soon be part of our everyday life? Today, we'll decode the full evolution, the design, the engineering, the real-world need, and yes, the battle with XPeng's IRON robot. Let's step into the world where mechanics meet intelligence, the future of humanoid engineering. Figure AI was founded in 2022 with a simple but massive goal: to build robots that can work like humans. The world is running short of workers in factories, warehouses, and care homes. Repetitive and risky jobs still need people, but not for long. That's where Figure AI stepped in. Their first creation, Figure 01, arrived in 2023. It looked human-sized, about 5 feet 6 inches tall, weighing 60 kilos, but it moved awkwardly, with poor balance and slow reflexes. Still, it was the first real step toward a humanoid workforce. Let's talk engineering. Each generation of Figure robot improved in mechanics, sensors, and brain power, just like upgrading a smartphone every year, but with legs. Figure 01 had only 28 degrees of freedom. That means 28 movable joints. Its motion was robotic because it used simple electric motors with no flexibility. Then came Figure 02 in 2024, upgraded to 41 DOF, full hand and finger movement, and a more stable walking gait. Engineers added hydraulic dampers in the knees and spine to make its balance more natural. Now in 2025, Figure 03 takes a smarter leap. It actually drops to 35 DOF, but uses compliant actuators, tiny electric systems that act like human muscles. These actuators can bend slightly when they meet resistance, making every movement softer, safer, and smoother. Inside every humanoid robot, the true magic lies in the power and control system. Figure 01 used OFF-board power. It had to stay wired for testing. Figure 02 got a small onboard lithium battery pack, 2 hours runtime, limited strength. But Figure 03 carries a 2 kilowatt-hour GAN battery, lasting up to 5 hours on one charge. It powers 48 V motors, sending torque data to the onboard controller 1,000 times per second. That's faster than the human nervous system. For brain power, Figure 01 had just 100 tops. That's trillions of operations per second. Figure 02 used NVIDIA's Jetson Orin at 300 tops, and Figure 03 runs a custom Helix processor at 1,000 tops, 3 times faster. This means it can see, process, and act almost in real time. Now, what gives these robots their sense of the world? Figure 02 added 3D LiDAR, microphones, and joint sensors. But Figure 03, it's loaded. It has 12 HD cameras around the head for full 360 degrees vision, 4 sensors in every finger, and pressure sensors under the feet, all working together with an AI system called Helix Vision Language Action Model. That means the robot can see an object, understand what it is, decide what to do, and act, all without human code in that moment. That's real autonomy. Okay, but let's be honest, Figure 03 still doesn't walk like a human. Why? Let's break it down technically. First, actuators. Human muscles are flexible. Second, feedback delay. Even at 100 milliseconds, it's slower than a human reflex. Third, simulation gap. Robots are trained in perfect virtual worlds, but real floors, friction, and uneven surfaces confuse them. So the robot's brain is smart, but its body physics isn't there yet. That's what engineers worldwide are racing to fix. Now the real question: where will robots like Figure 03 actually work? Here's where engineering meets real life. In factories, humanoids can replace workers for repetitive tasks like sorting, welding, or packaging. No redesigning the factory floor, because they fit where humans do. In warehouses, they can lift 25 kilograms safely, thanks to torque-controlled joints. In hospitals or elder care, future models could assist patients, deliver medicine, or even provide company. And in space exploration, NASA and SpaceX already study humanoid bots for operating tools where humans can't survive. So yes, this isn't sci-fi anymore. It's applied robotics. Now let's have a quick showdown. Figure 03 versus XPeng's new IRON humanoid, revealed in November 2025. Let's start with flexibility. Figure 03 has 35 joints, while IRON has a massive 82. That means IRON can twist, bend, and move almost like a real human. Next, the brain power. Figure 03 runs on 1,000 trillion operations per second, but IRON triples that with 3,000 tops. So yeah, IRON thinks faster. Both walk at 2 meters per second, which is about a normal human pace. Now battery. Figure 03 lasts around 5 hours, but IRON goes for almost 8 hours non-stop. The body material. Figure 03 uses soft silicone skin, while IRON uses a lattice-style soft skin that flexes and even mimics muscle tone. But here's the twist. Figure 03 costs around $20,000, while IRON, a jaw-dropping $150,000. So overall, Figure 03 wins for being practical, affordable, and efficient. IRON wins for looking more human and more powerful. It's like comparing a smart electric scooter to a luxury sports car. Both are amazing, but meant for different worlds. And across the world, a new race is on, the race to build the perfect humanoid. From Boston Dynamics, creating the jaw-dropping Atlas that moves like an athlete, to Tesla's Optimus, built to work beside humans with precision and power. Figure AI is teaching robots to think, learn, and move naturally, while Agility Robotics brings Digit to life, ready to lift, walk, and work in real warehouses. In Japan, legends like Honda's Asimo and Toyota's THR3 laid the foundation for this revolution. And then comes Engineered Arts from the UK, giving us a mecha, the most human-like face ever built on a robot. So, what did we learn? From Figure 01's basic frame to Figure 03's smart muscles, the journey is pure engineering magic. Humanoid robots aren't dreams anymore. There are next-generation helpers for homes, factories, and maybe even Mars. Would you buy a $20,000 robot for your home? Tell us in the comments, and don't forget to like, share, and subscribe.